We are facing a new chapter, Chapter 1, Symmetry and Surface Area. We've got three main sections, although the third one is split into a couple of pieces. The first one, lines of symmetry, that's what we're going to deal with today. Rotational symmetry and transformations is up next, then we'll have a quiz, and then 1.3, there's a little bit of a review on surface area of 3D shapes. Then we'll have actual content on surface area of complex and composite objects, some review time, and then your exam. Inside of the cover, we've got our I can statements for today. I can identify lines of symmetry of a shape given its color and design, and I can draw the other side of a shape given a line of symmetry. And then we've got some more for the rest of the chapter as well. Here we go, 1.1, line symmetry. We've got a couple of definitions to deal with first. First up is line of symmetry. It is a line that divides an object or design in half, where both halves are the same. Each side of the line is a mirror image of the other. It can be vertical, which is up and down, horizontal, like the horizon, that's side to side, or oblique, which could be considered slanted or diagonal, that sort of thing. Slanted, or the word that could go here is diagonal. The line of symmetry is also called a line of reflection. So that's kind of another term here. And a figure or an image may have more than one line of symmetry. So in this house type shape, we've got a vertical line of symmetry right down the middle. Both sides are exactly the same, mirror images of each other. On an uppercase letter E, we've got a horizontal line of symmetry down the middle. Top and bottom halves are mirror images of each other. And of a rotated square, we've got oblique lines of symmetry. These are diagonal lines, and both sides of each of those lines are mirror images of each other. So that's a line of symmetry. There's also something called line symmetry, which is a type of symmetry where a line of symmetry divides an image or object into two identical reflected halves. So basically the same concept. Identical halves can be reflected vertically, horizontally, obliquely, using the line of symmetry. Yeah. All right, example 1. Finding lines of symmetry. Each diagram shows line symmetry. For each part, use a different method to find the lines of symmetry. State the number of lines of symmetry and describe each one. So this is going to take some work to get used to this, and I do not have a mirror to be able to do this properly. But if you notice, if you cut this in half, like that, you've got one particular shape. If you look at the top half, it's exactly the same. If you try and divide it with a vertical line, that piece that's there does not look the same as this. And diagonally, you'd be faced with the same thing as well. So this has one horizontal line of symmetry. And this diagram here shows the use of a mirror. If you hold it on this line of symmetry, and if it reflects properly, it looks like the original image. You can see that this reflection on the close side is shown here, and it looks like the original diagram. New shape, sort of an hourglass on its side. So you can count squares on the grid to find your lines of symmetry. So you probably recognize that, again, it's a horizontal line of symmetry, but there is also a vertical line of symmetry. You need to try and find the middle of the shape to be able to figure that out. So let's start here. There's 1, 2, 3, 4, 5, 6, 7, 8 boxes used for the height. So half of that is 4. So if you find 4, that's 4 there, and this is 4 here. So you can draw your horizontal line at that point. And so now you can see that the two halves, the top and the bottom, match each other out. You can use the same process for finding the vertical line of symmetry. You can count the full length of the shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. So half of that is 6. So if we count 6 off on one side, 1, 2, 3, 4, 5, 6, that's going to put us right here for this other line of symmetry. And we can draw that in as well. And you can see that the left side and the right side are reflections of each other. So in this case, this is going to be the center point there. That and that are not reflections of each other. And likewise, neither is this and this. So we don't have any oblique lines, but we do have one vertical and one horizontal. So we've got 2 lines of symmetry for this particular object. So one line is horizontal, and one line is vertical. Next shape. We can use folding as well. If you've got it on a single piece of paper, you can fold it in half to see if it looks the same on both sides. And if it does, then we've got a line of symmetry. So taking this shape, if it was on a larger piece of paper, we could fold it. And you could check the horizontal line. And you'll notice that yes, horizontally, it is symmetrical. We also have a vertical line of symmetry that works. Both sides will be the same. But in this case, we've also got oblique lines. And there's 2 of them, one in each direction. So on the original shape, you can have a line here. You can have a line here. You can have another one across the middle, horizontally. And another one vertically. So we've got a total of 4. So there's one horizontal, one vertical, and 2 oblique lines of symmetry. And they go in either direction. All right, next up is a show you know. Give it a go.